All right, for number 7, we have an airplane traveling in the direction of 50 degrees. So now 50. Again, we are talking about direction now, and north is always 0. And east is 90 degrees, just for your reference, quick reference. So 50 degrees means we are traveling northeast, okay? Northeast with a speed of 300 miles per hour. And then there's a 40-mile-per-hour wind with a direction of 120. 120 degrees will be in the direction of southeast, okay? So I'm going to draw my diagram like this. Okay, so this is where we start. And now, again, when you draw your vectors, try to draw a good diagram. Make sure that the lengths are somewhat to scale. Somewhat, okay? That's what I'm looking for, somewhat to scale. Okay, so this is 50 degrees, okay? And the length, it's 300 miles per hour. And just out of curiosity, what is this angle right here? Okay, I hope you are thinking about 40. Okay, is it useful? I don't know. We'll see. But out of curiosity. And then we have the wind. Now the wind's going to push the airplane a little bit to the southwest direction for an angle with an angle of 120 degrees. And this is a small number compared to the 300 miles per hour. So let's just draw a small arrow, 400 miles per hour. And just out of curiosity, what's this angle? This angle is 60 degrees because 120 plus 60 is 180. Okay, is it useful? I don't know. We'll see. Now, we want to find the resultant. So we want to find out what is the actual ground speed and the course, meaning the direction that the plane is actually flying. So that means we are looking for this direction as well. Okay, this is our ultimate theta. And in order to find the length, we need some angles. We actually need this angle first. So what's the magnitude of this angle? Wait, hold on. We were curious earlier, right? We were saying that this angle it's 60 degrees, right? 120 plus 60 is 180. And what about the other side of the angle? Wait, hold on. That is the alternate interior angle. If you can see it, this is 50. The alternate interior angle. This is the alternate interior angle, so that it's also 50. So that's 50 right here. So 50 plus 60, you have a total of 110 degrees. So the length of the resultant is x is equal to the giant square root 300 square plus 40 square minus 2 times 300 times 40 times cosine of 110 degrees. Okay, so make sure you are using the diagram to tell your angles and draw a big enough diagram so that you have an easier time to tell the angles. So 30, 40, 110, all right? So let's go ahead. 300 square plus 40 square minus 2 times 300 times 40 times cosine of 110 degrees. So that gives you this number, and then you need to take the square root, so raise to the 1/2 power, 315.925. So the speed is 315.925 miles per hour. Okay, so the wind, the southeast wind, it's gonna push the plane a little bit faster to the east direction, but also pushing it more towards the south. So that's good. But now, what about the direction? What about the direction? Well, we know it's more than 50 degrees for sure because it's more than 50. I mean, if you open your eyes and take a look at it. But what's the angle though? So we will need to find out this little angle right here. Okay, we need to find out this angle. Well, how? Okay, let's call this theta prime. Okay, so we'll say sine of theta prime is to the 40 miles per hour. And then sine of 110 degrees is to the new length that we just found earlier. Okay, 315.925. So we have sine of 110 degrees divided by 315.925. Okay, and then times what is it? 40 miles per hour, right? So that would be the sine theta prime, and then inverse of this number would give us 6.833 degrees. So this little theta prime is 6.833 degrees, which makes sense because it's pretty narrow. Okay, and that's why a good drawing is very important. Now that's just theta prime. What's the actual theta? The actual theta, the bearing, the course, it's 50 degrees plus 6.833 degrees, which is 56.833 degrees. That's a course. So the speed is 315.925 miles per hour at a direction of 56.833 degrees.